the video, because I know there were some people who were not able to make it today who wanted to be able to watch. I don't know if they're going to try to watch it in real time.
And of course, I will replace the draft version with the final version later on, plus comments and questions if needed.
We are.
We're up? Alrighty, so welcome back online. Alrighty. Are you ready?
I am.
Oh, you have notes. That's not fair.
No. I just, if someone has some question, I will take notes because. Okay.
All right, I'm going to go ahead. So I know Xavier had asked if there was a space that he could write and draw pictures on. So the whiteboard is
Perfect.
ready for you. So.
They're all in the back, so we've got plenty of blackboard space in the back.
So, morning everybody. Going to speak about DNS. Hopefully you're here for that. That's my name. Don't worry about how you can pronounce it. If I understand it, it's fine. And my email address if you want to reach me later on. If you feel that's a good presentation and you want to reuse some of it later on, feel free to do so. It's Creative Commons license, so you can reuse that as long as follow the rules. Who am I? I've been using Linux since '99-ish when I started studying in IT, and I've been using Linux ever since then. Not Linux only, but mostly. I'm a network and system administrator. I have a CSSP. You will probably notice that on many occasions I will point something related to security issue with DNS about, oh, it could lead to this or it could lead to that, because that's what I do. I'm trying to stay focused on security. And I've been exposed to DNS servers in one way or another since 2001. So I've been able to manage different domains on different systems for different reasons. I have some experience, some knowledge. I'm not a full expert. I don't know everything understand in DNS. So if you ask for some specific question, I may not be able to answer, but hopefully we'll get there. Just to have an idea about the audience, how many people have already in some ways managed a DNS server? Okay, fair number. So you should already be familiar with some of that. Hopefully you still be able to learn something. Okay, first basic obvious reason is, why do we need DNS? So as you know, computers are speaking to each other using IP addresses, IPv4 or IPv6, and as human beings, that's not something that we are always comfortable with. So we are using names. And the DNS is the service that will translate those names into IP addresses and vice versa. That's the technical foundation for DNS. As a matter of fact, over time we realized that DNS is important to us some other level. DNS means that you get a name. You can use a specific name for your company, for your organization, for yourself, and that's important because you want to keep that name because it's your identity as long as you can. If you start a company and okay, my company is going to be XYZ, whatever, you want to make sure that you're going to be using that name for 10, 20 years, 50 years. No matter how many IP addresses, service provider you will be working with over time. You want to make sure that that name will remain stable. And over time you may be working with different contractor, third-party service provider, and the IP addresses that you will be working with are going to be changing. Or you will migrate to IPv6 eventually. So that's something that's important with DNS. It's a system that's really designed to be stable. Not only for the technical part to make sure that the service is up and running, but also that the service that's provided remains stable for the end users. End users will never ever learn an IP address. They will learn a name, and once they've learned a name, they're going to stick with that.
I would add that the IP address is often changed, so we don't want them to remember the IP address.
Anyway, and I mean, Even with the name, sometimes the end users are not really that smart because they are going to Google to type the domain name in the search bar instead of the whatever. Of course, there is also a technical reason about some names are shared by different IP addresses, and some hosts are using the same IP addresses for different domains. So we do need DNS. There is no way for us to use internet as it is right now if we don't have DNS. Okay, so you probably have already seen that kind of diagram more than once. DNS is organized as a tree with the root on the top and branches and leaves going to the bottom. And the root is just a dot. It's an invisible dot when you type a name. Most of the time, you don't need to put the final dot. It's automatically included. But it's just a dot. And then you have the top level domain. There is a short list here. So all of those, you should be familiar with those. That is where it comes from. Japan, Aero, XYZ does exist. If you go to abc.xyz, that's going to be Google. That's the domain name that they've used for Alphabet, the new company that they have founded in some house. If you're familiar with the TV show Silicon Valley, there is the company Uli, and Uli XYZ does exist, and it's some stuff related to the TV show. What's important with the DNS, it's really working as a tree. So you have a root, then you have a first branch, and then you have another one, and it goes finally to some host. There is some technical limit about how long you can have a domain. There is a limit about how long a leaf could be. It's very rare to reach those limits, but they do exist. Right now, we have more than 1,000 different top-level domain, between the generic top-level domain, .NET, .edu, .com, etc., plus all the different countries, and plus some new generic or new specialized domain that have been created during the past few years. So if you're reading some materials related to DNS from 10 years ago, where they were saying, okay, it's only about those domains and you're fine, it's not true anymore. You really need to rely on DNS as the system is set, because you're basically not able to know from top of your head all those domains. I will be working with example.com for most of the slides, so feel free to replace that with your preferred domain name. Where does it come from? Where that idea of planting a tree from the top came from? At the very, very beginning, in the old times, when it was ARPANET, there was no DNS, but there was not so many machines on the network anyway, so everything was managed manually in a file, that host file, because it was listing all the hosts on the network. And of course, it didn't scale, because at some point you have just way too many entries in that file, and it was managed manually, meaning no, you're not going to get a new domain name during Christmas break, because the people who are working for that are on vacations. So John Bostel, who is one of the internet founders and guy who has been responsible for everything that we are using right now, has been discussing with another guy named Paul Macavegres, and they were trying to figure, okay, we could use this or we could use that, etc. But Paul finally got a new idea on his own, and it was DNS. And what's really interesting is the original concept of DNS from the 80s is basically the same that we are using right now. We're expanding it, we are building on top of it, but all foundation remains the same. And of course, everything has been officialized with a couple of RFCs, and that's like really the old one. You can look at those for historical reasons. There is still some good parts in those documents, but it's been superseded by a lot of other RFCs. How does it work? So your computer starts connecting to the network and it knows basically nothing. The best thing that he will receive is an IP address and the different network settings from a DHCP server. And among those settings, there are going to be 1, 2, 3 DNS servers, addresses. And that's it. Your computer doesn't know where Google is, where Red Hat is, where VeriSign is, nothing. So you open your browser, you open your mail client, you're trying to get some stuff coming from the wide world, and the first thing that your computer will realize is, I don't know where it is, so I need to ask someone. Your computer will ask the local resolver, the nearest DNS servers, not really near in the geographical sense, just the one that he knows that you received the IP addresses from DHCP. And the local resolver will realize, okay, do I have a response for that question? I already know maybe what is the IP address for that service? And then, if so, then you get a response immediately. If it's already in cache, if it's already in memory, it's super fast. If not, that's going to be a long process that I'm going to explain in a minute, and then you have a series of queries that are sent on your behalf to receive the response. It's a really, that's something that's really important when you manage a DNS server. The DNS server should be able to respond very quickly. Because if there is any delay, if there is any timeout whatsoever, the user experience on the other hand is going to be horrible. Because timeout, okay, I'm going to ask another DNS server, whatever, and it's just going to be super slow. Sometimes when you have people saying, oh, my internet connection is broken. No, you may just be using a DNS server that's not up and running, and that breaks the internet. Or if you have a super DNS server that just overwhelmed with too many queries from other clients, then you will have that slowness going on. So that's something, when you manage the DNS server, that's something that you need to make sure that the responses are coming very quickly. All the traffic is sent using UDP 53, in some situation TCP 53. If you're managing the firewall on your DNS server itself or on the network, make sure that those two are open, and your DNS server should be able to reach any other hosts on the internet on those two ports. Should not have any restriction about, oh, I want only those specific addresses. No, it should be completely open. So, explanation with a good diagram. Your client doesn't know anything and he wants to ask something, what's example.com? And it's going to ask that to your local DNS server. Yes?
What do you mean by local? I've got an
Uh-huh.
there.
There might be one if you set it up.
I didn't say that.
Okay, so
So, let the speaker.
okay, so most likely there is two situations, assuming that you have not set anything by yourself. There is two scenarios. The one is your ISP, your internet service provider, will provide the DNS server for you somewhere on its network, and your computer, when it's connected with the modem router, will get that address. More and more often, the modem router acts as a DNS server just for your network. Even if it's a super small box that doesn't do much, it can at least do a DNS queries. So, and that will contact most likely the DNS server from the ISP, and then it will go. But by default, when you're at home or any places like here, there is a DNS server on the same network, most likely, that will be the one that we call the local DNS server. Doesn't mean that you cannot bypass that by setting something different, but we will talk about that later. Okay, and let's go with the worst possible. Sorry, your local DNS resolver doesn't know anything. You're asking for something that it doesn't have in memory. And that guy is not going to should not make up a response. It should give you the real thing. So local DNS server is not pretty smart. It's a little bit smarter than your computer, but it's not that smart either. It doesn't know how to find example.com. The only thing that it knows is how to find the root. Because built into the local server, that machine will know by default all the root server IP addresses. That's part of this package when you install software. So since that's the only guy that he knows, okay, what example.com? The exact same question. It's really important here. Any DNS server during the whole thing will not truncate or will not mangle that query. Each time the query will be sent, that's going to be the full thing. Because first, that server doesn't know where to split. We know where the dots are. So we could say, okay, we just need to know where .com is, and then we will figure the other stuff later. But DNS server is not that smart, and in some situation, some specific countries or top-level domain, it's not that obvious. For instance, in UK, they have .uk for their top-level domain. But under .uk, there is a lot of other subdomain like .com.uk or .gov.uk. And those could be managed by different servers in different zones. And the DNS resolver, the local one, doesn't know how those zones are split. So it will always query with the full thing, and it will just try to work backwards from the end to get the final response. So that root doesn't know where example.com is, but it does know where .com is. The root server does know only about the generic top-level domain, just about that 1,000 domain. And goes again, what is example.com? I don't know, but I can probably give you example.com. You're getting there. Example.com is what we call an authoritative server. That guy is the official source for everything in that domain. That's the guy who manages. And so it can provide a full answer about, okay, you want that the IP address for that name, that's going to be that IP address. And then it goes back to your client, finally. And at the very end, you can reach that web server that you were looking for. So that's the worst case scenario when you have multiple questions. Of course, we're asking for www.example.com. If we ask for something that's under another subdomain, you will have another round of queries, and we'll just make a little bit more time. But that's the worst case. If you already have something in memory here, because most likely that server will already know about .com. So that means that you will probably be able to skip the root, skip .com, and maybe just sending a query to example.com, which is 1, 2, 3, 4, 5 trips. So that's faster, definitely faster. And if it's, let's say, instead of example.com, it's like facebook.com, something that's used a lot by other people on the same network than you are, then the memory is going to be already there. It's already going to be in memory, so it's going to be definitely faster. Few comments about this. First thing is, what's really make the difference is the memory. So that means that your server needs to be up and running for as long as possible, as long as you can maintain it. Not only for the physical box with power and stuff like that, but also for the service itself. You don't want to restart a DNS server just because it will do some good. It will definitely not do any good to restart a DNS server if you don't have a good reason. Because if you restart the DNS server, you will wipe everything that's in memory by default. Then you will start from scratch again, and that will take time to build up. So anytime you're managing a DNS server, make sure that it's really maintained properly. So obviously, you don't want to have any other service running on that same box. You don't want to run, I mean, there is a couple of exceptions, but in general, you don't want to have a FTP or HTTP server on the same box. That one should be dedicated to DNS. On a different note, since the question is pushed and propagated and goes everywhere, that means that the people who are managing those servers, if they're looking at the logs, they can see exactly what you're trying to do. They can see exactly what websites or SSH server or anything you're connecting to or your computer is connecting. So you're probably going to say, yeah, but Google already knows all my search history. No big deal. Probably not agree with that. But the DNS is more special because when you're searching on the web with a search engine, you have a search history, and that's only about the web stuff. When you're using DNS, it will also store everything about all the SSH server that you're connecting, or the mail server that you're going to connect to, FTP, and so on and so on. There is a fair number of resources that we are accessing that are outside the web. And Google and the like will probably not catch all of that, but the DNS will do. DNS will keep all of that in memory at some point. There is a couple of groups from the ITF working on that right now to try to figure, can we change the query mechanism to query only what's needed. There is currently also, there is no encryption. Everything is in clear on the wire, plain text everywhere. So there is also a discussion group about, okay, can we encrypt all of that traffic so that way nobody can spy on that? Which is kind of not super easy because by default we're using UDP because it's fast and efficient. But if we need to encrypt something, that means that basically we're going to switch is more resource consuming. So there is some people working on that right now. It's not ready yet. It's still in the works, but there is some progress.
DNS script.
Sorry?
DNS script.
For
The protocol for
Yep.
queries.
Yep. So back to the same diagram. All those that translate in the current internet that we're using for. So to answer your question again, this server could be hosted by your ISP. By a third party, you can use Google Public DNS Service. You can use VeriSign Public DNS Service. There is plenty of DNS servers that are that you can openly access and use instead of the one provided by your ISP. Or you can have your own at home. Why would you change this? Why would you have one extra box running in your basement? There's different reasons. One would be beyond the fact that it's fun. That's just me. You have more control about filtering and security things. If you want to make sure that nobody on your network can have access to some specific website, and you want to block that as quickly as you can try that, doing that on the DNS. There is a different way to do it by subscribing to some public list or managing that manually, but you can control that. If you are at home, it may not be needed, but for a company, for a public library, maybe it could be useful. Your ISP may be lying to you. I mean, it's not maybe lying, they are lying to you. I don't know for any old ISP in the area because I'm just a client for one, Verizon. And if I type something and made a typo in my web browser, I still get a response with like tons of ads because their DNS servers are configured to give an answer no matter what. And so you land on a page that like a search page and you have plenty of results and it generates money for that company, which is fair in some ways. I don't know, not
It
sure.
probably screws up a whole lot of protocols that depend on getting the no such domain.
Exactly. The problem is, from a network standpoint, if something does not exist, you should not get a response.
So you should get the.
Or yeah, or a response that said doesn't exist, but you should not get something positive. So yeah, if you are in a hotel, airport, or any of those places where you have a guest Wi-Fi network that's managed by squirrels, most likely you will have some weird DNS stuff, because before signing to a portal or something, you will probably not be able to reach the DNS server. That's usually one of the methods. Or you can have your own, and we will talk about that a little bit later. The root server, if you look at the list of the root servers, it's 13 different addresses. It's not 13 physical boxes. There is way much more than 30 servers. And they're available through Anycast, which means that the same IP address, because of some routing specifics, the same IP address is used on different boxes all around the world. So that way, when you need to reach one of the servers in that list, you will be reaching the nearest one. And in that sense, it's going to be the geographical nearest one to your connection. And so that way, you will still be able to reach one DNS server no matter what. For the top-level domain, it depends from one domain to another, but they are definitely running multiple servers. For .fr, for France, I do know that they have 8 addresses. 4 are located in France and 4 are located outside. So meaning that even if, God forbid, France is wiped for whatever reason, Russia or Chinese or something, we still have DNS servers elsewhere. And that kind of scenario did happen and did work properly a couple of years back. Haiti, you remember the earthquake? They've lost internet connectivity, they've lost everything, power, whatever, a lot of people. And their domain name was still alive because it was also running on other services around the globe. So redundancy is provided by having multiple servers when you manage domain. And when you're managing your authoritative servers, so at the very least you have one primary, and you have multiple secondary, and depending how critical it is for your business, you can have secondary on a different network, a different provider, or you can have multiple service. You can run that with Amazon Route 53, and you can host your DNS servers up there. It's not the only service, it's one that's well known, but you can have different providers managing your DNS server, full or partial service. And that way, we will see a little bit later, but your domain name can stay up and running even if one of the server is going down for whatever reason for maintenance. Also, something that you probably can see in different documents and the like, I'm using primary and secondary. Sometimes you can find master and slave. Don't like that terminology, so primary, secondary. Secondary means that you can also have many secondaries, not only one. The root servers.
So primary,
Yes.
master server, slave is what bind users for that terminology.
Yeah, regarding the DNS terminology, there is a lot of terminology that has been defined by the bind documentation, because bind is like the de facto standard. So a lot of people have been learning bind first, and so people are reusing the same terminology coming from that document. The 13 name server, the root servers, are operated by different organizations, which means that it's somewhat neutral, and they all agree on doing the same thing to provide the same service. But the way that the servers are managed on a day-to-day basis, they are not using the same software. They are not using the same hardware. They are using different connections. They have probably different way to deal with updates and stuff like that. So that means that if someone wants to attack and take down the root, it's not going to be one target. It's not going to be 13 targets. It's going to be way much more difficult. And as today, a lot of people have been trying to take down the root for different reasons. Never worked. best 1 or 2 servers have been taken down, but not 30. So that's something that's really reliable. Yes.
A quick question on the root. Just wondering, so the root is manually managed? So
No.
they've got to manage, 13 servers have to manage more, I mean.
So yes and no. And I don't have the exact answer because I don't work for one of those organizations. I've never been there, and they don't provide that much information. It's probably managed manually in that sense that they're not updating a lot of domains on a regular basis. They don't create a lot of new domains every day. So there is probably nothing that will push something automatically. It's probably manual in some ways, but it's probably automated in that sense that they're relying on databases or some other records stored somewhere else, not only for the domain, but also, you know, for who is the person managing that, who is the organization, etc. So there is extra set of information that's kind of related to the DNS system that they are probably storing somewhere. Yes.
So the one thing I would say is if you go back 5-10 years ago, right, there were basically 4. Right? You had ComNet or EDU. Right? And then they decided to open up, right? And then, well, I guess they had the countries also, right?
Yeah.
But then they opened it up to now you have .info, .biz, XYZ, and the list goes on. So now they're probably slightly more busy than they were 10 years ago. And I would assume, if Peter, you go in a second, I would assume that they're using some sort of management. So these guys have been doing it, so they took their time and they went through. It was a long and lengthy process to open up the root level. So I imagine that it wasn't, you know.
Still only 1,000 names, and they all easily fit.
Right, yeah.
It's not the data amount that's the problem. That picture you're looking at there is momentarily. So one of the things that you do when you set up your own domain server is that you have to maintain a good list of those root servers because they change. That's their job. That cache, that information is spread around, and it moves around because of attacks and other things that are happening. And it may be that, hey, all of a sudden there's a link down, a data center down. They got to put something up. So a lot of their work is about how do we propagate this data out and inform all these major servers that we now have more caching over here. And as you say, they may also decide, hey, there's certain links or other things that we want to store in memory, like Facebook, Google, and all that, and that, so you don't have to go back and forth all the time. All that takes memory, and all that takes management. It's not like they're adding domain names. That's been outsourced, or whatever I want to call it, to the .com guys, to the .net guys, or France, or whatever, right?
So I will go quickly on the root server because, I mean, we can speak a lot about that, but there is other stuff to cover. But basically, what you need to know is different servers spread across the globe and managed by different organizations. There is that website, rootservers.org, which is an official website where you can see where they are located in some ways. Just around the DC area, we have plenty of DNS servers. And it's not a surprise because guess what? VeriSign, Reston. Cogent, probably nearby. NASA, the headquarters are in DC, but they have probably a couple of network stuff around here. University of Maryland, not very far. DoD, that's here as well. So because of a lot of organizations tied to Washington, D.C., then you have a lot of servers that are located here. You have also a fair number that's located on the other coast. And of course, you have everything everywhere. And what's also important is those locations are the ones with a very good network connectivity for backbones connectivity around the globe. Okay, let's start. So it's going to be a lot of acronyms. Yay, that's what we do in IT. Okay, SOA and NS. And yeah, sorry if I mispronounced some stuff, but I have a funny accent. You've already noticed that. Okay, start of authority and name servers. That's for regular hosts, that's for email, and there is plenty of other type of record that you can use in DNS. Most of the time, if you manage just a basic server, you will deal with that most of the time, 90% of the time. But there is a lot of other stuff that you could use. There is even something to put the GPS coordinate of your router if you want. Not sure that anyone does that, but also, back in the day, it was only ASCII character, AZ09 and a couple of symbols. Not true anymore. You can put something in Arabic, in Russian, in French, or whatever, with accent and fancy writing.
How common is that in fact? Because I know that from other European countries, they're not doing that.
So yeah, so first it requires for the country, because it's usually tied to a country. It's not for .com or something. Will not probably be doing that anytime soon, I guess. So it means that the country will ask ICANN for a top-level domain with that specific glyph writing, and then they will get authority on that zone, and then they will be able to create as many domain and hosts with the spelling that you want.
They use Unicode.
And so, yeah, it's Unicode. I'm not going to explain it all in detail so it works, because I'm not quite sure about how it works myself. But basically, it will translate anything that's Arabic or Russian or whatever in ASCII using extra strings of character and make sure that it fits exactly where it should be.
Way of encoding Unicode into
ASCII.
ASCII.
Yeah.
Yeah.
Yeah. And
And Microsoft uses UTF-8, which totally screws things up.
okay, startup authority. That's really the thing that you will need to know if you manage DNS, because this is where everything starts for your domain. You will have the primary name server for that domain is going to be listed there. A contact email address. There is an email address listed in that record, so that way if something really goes bad, you can try to reach to that email address saying something's wrong. And you have different time value about, and those values are used by the secondary servers only to figure how often they should contact the primary, and when they get a response, or for how long they should be keeping that in memory. And it's really important because that's how the system is resilient. If your primary goes down for whatever reason and you don't notice that your primary goes down, you're not in trouble yet, because your secondary will just maintain the service as is. No updates, but nothing lost either, because there is still something in memory. And when your secondary will realize, oh, I need to refresh my data because I have reached that value, let's try to contact the primary. Primary is not responding. Hello. Okay, well, I'm still running. I'm going to keep that. At some point, some stuff will expire because it's not going to stay in memory forever. And the secondary will retrieve more than once about where is my primary, where is my buddy. And when your secondary will not be able to get anything in memory and will not get any responses for the primary, then the real trouble starts, because you will lose everything for your domain. Primary dead, secondary dead, you're done. So you need to make sure that when you're working with those values, you need to know exactly what it entails. That means that, okay, if my server goes down, how much time do I have to react? You need to know that at some point. And there is some values that are recommended by the RFC about, okay, should be 1 week, should be 1 month, etc. The NS records will list all the DNS server for the domain.
Can I add one more little dimension? This is why when you go out and create a new domain or something like that, that they say it will take it a day or so to propagate.
Yeah, because the other servers that are not part of your organization will need to run a lot of queries before getting that fresh response. So there is always that propagation issue. It's also true when you make some changes, especially when you use the same name and you change the IP address, and then you still have people trying to connect to the old system that's down, then you need to use there is some timing that's related to DNS that you can tweak. You can, if it's something that you're planning, you can reduce the time of life of your record, so that way people will get a response for a short period of time, not keeping that in memory for too long. And then you make the switch, and then you're increasing, you put the TTL back to what it was again. That's when everything goes well. Of course, if it's emergency, it will probably not work that way.
And there's one more aspect, that's the serial number. Just mentioned. Then the
Yeah. So this is how it looks like when, so the command to troubleshoot DNS, there is different commands. One that probably everybody knows is NSLOOKUP. NSLOOKUP sucks.
Thus,
Okay. So if you are on any recent modern system, you have dig, use dig. If you're on a Windows box, you can install dig, and you can survive. Okay. Dig SOA example.com, and that will run the query, and that's the response. It's truncated, hopefully you can read that from the back. So that's the domain name. That's the TTL by default. It's the internet class. That's the type of the record. ns1.example.com dot. That's the full qualified name for the primary server. hostmaster.example.com is the email address. It's part of the standard. The first dot should be replaced by the @ symbol. So if you have any problem with that zone, you should be able to contact hostmaster@example.com.
So this means that you cannot use email IDs with a dot in the name, right?
Exactly.
right, but Hostmaster is a very standardized.
Yeah.
You need to have a separate account. What I find funny here is, my domain server for example.com is not working, send an email to example.com.
Yeah. So
You
usually,
shouldn't do that.
yeah, usually you have a domain contact center that's outside your domain, because depending how critical the problem is, if the DNS server is down, the email server is going to be not responding. So usually you try to put something outside. So that means that could be a Gmail address or whatever, but something that you can reach outside your network if needed. And you have the different, so I'm going to get back to that quickly. And you have the different timing for refresh, retry, expire. All of those are in seconds by default, but when you configure a DNS server, you can put 1D, it says 1 day. So it's easier to manage. And there is a serial number. Serial number is a way for the secondary server to check if they are up to date with the primary. In theory, you can have just an integer 1, 2, 3, 4, 5, and so on. And this is what some DNS software does. It's just something that increments one by one over time. And it works. It's just not super practical, because you don't know, oh, the version 55 is from 2 weeks ago, 3 weeks ago, I don't remember. It's 55, so you just know that's more than 54 and less than 56, that's it. So the very common practice is to use 2017, 05, 16, 01, year, month, day, version number. And so that way you know that that record is from May 16, 2017, and it's the first revision. And there is a lot of people who are doing that, so that way you can compare if very quickly if you have something up to date or not.
But there's one small caveat in that. If you are dynamically updated DNS, your dynamic update don't follow. So if you start from that, it backs it up. And that's what I realized later.
Yeah, I'm going to discuss a little bit about dynamic updates, because each time you make a change in your DNS system, you need to update that number. You need to increment it. So if you're making 3 changes in a day, you're going to change the version number.
But all your dynamic updates do is add one.
Yeah.
Right?
Yeah.
So it doesn't really matter, because because you have the date in there, all that's going to happen, unless you have more than 99 in a day, then
No, but it won't update the next day when it happens. It won't update the date. It just increments.
But it doesn't matter when you update the date. Now you're a higher value anyway. Right?
Yeah, Xavier, I think, is going to go through this. important thing to know is if you're managing your own DNS, there are two things that are common mistakes, and I'm sure you're going to bring this up. One, forgetting the period after the domain, right?
Yep. If you
So
don't have a final
ns.example.com dot, you will forget that dot the very first time you do it, I guarantee. And if you don't, let me know. And the other thing is you'll forget to update the serial. And when you reload, so one of the things under Unix is you usually do a reload, not a restart.
Yeah.
And so what that does, it tells it to read this file. And so you've made a change, you don't change the serial, you do a reload, and you're like, why is it giving me the wrong IP? Didn't update that serial. So those are the two things that you will bang your head against at least once in your professional career if you're managing DNS.
I did that. And especially
It's
true
a
because
right
when you maintain a zone and you have different files and each file will have a serial, you need to make sure that all the files are up to date. And of course, because you're in a rush, you're updating one, you're updating the second one, and you forget the version on one of those two. So yeah. NS, that's just to get the list of all the name servers for zone, so that's pretty simple, pretty straightforward. Yes.
The way you handle that rollover problem that he was talking about, like here on the 16th, and add 1 to 1700, that's not a problem. I use a script that updates it and it puts in the date, but always make sure that the new, but if the date conflicts because it's rolled over, then it just adds 1.
So I'm just explaining how it works basically, but in practice, you have a lot of ways, script and tools to check it and make that process easier anyway. And there is some other stuff that I'm going to discuss. So just to give you the list of all the all the name servers in your domain, straightforward. Okay, that's really the core thing. This is for any single computer that you will have on your network, you should have one of those network record set. If you have a computer connected with IPv4, you should have an A record. If you have a computer connected with IPv6, it's going to be a quad, 4 A's. And if you have a computer that's connected with IPv4 and IPv6, 2 records, 1 for each. You will need a PTR record, a pointer, and so those are converting the name to an IP address. PTR will do the opposite, from the IP address to the name. It's used for some kind of verification sometimes. Not as useful, I mean, both are useful. It's not as used as the first two ones, but it's. And the PTR record, depending if it's IPv6 or IPv4, that's going to be in some special zone named ARPA. CNAMEs are here to create aliases. For instance, you're never ever going to name a machine www because you don't want to have that saved on your configuration files everywhere on the machine, because you know that at some point you will replace that machine and you're not going to put the new one with www2 again, but it's really not good. So you will have a generic hostname for your machine, web server 01, and then you're going to create an alias that says web server 01 is www. And you are using that for almost all the services that are visible from the internet. You should have CNAMEs almost everywhere. It makes the work easier when you change one machine with another, or if you need to split the load between different machines, etc. Dynamic DNS. So dynamic DNS is that fancy thing where you bring a laptop, you connect that laptop to the network, and the laptop will receive an IP address and some settings from the DHCP server. And during that exchange, during that discussion between DHCP and your laptop, DHCP will learn the host name of your machine. Mine is named Jupiter. Okay, Jupiter, whatever. And in some networks, you can have DHCP, oh, we don't have Jupiter on our network, so I'm going to register your name in our DNS. Okay, why not? Probably don't need that, but okay, go for it.
That's good reasons for it. Okay.
But the problem is, first it will increase the number of records in your zone, and that will need to require some updates on your zone at some point, depending how many laptops are reaching every day on your network. And also, it could be tricky about, okay, let's say I'm currently connected on Red Hat network, and I don't know anything about how the Red Hat network is set here, but let's say, what if, instead of Jupyter, I call my machine mail server 05. It gets registered into the DNS, and it's becoming mail server 05.redhat.com. It's probably not really official. So that's something that it works. It has some good features, but I would probably go against that, because depending how public the network service that you provide is, you may not want to have people registering some funny names in your domain, because they are going to stay in memory for a little while.
This is why you have a separate subdomain for your guests.
Okay.
Or for your DHCP network. Right? You don't want people to go in and grab your internal servers and all that.
And yeah.
Just put the dynamic DNS in its own zone.
Yeah, you can.
Right.
Yeah, so
And that
it
zone just has a simple sequence number.
Yeah, but
And you know that all the names in that zone are whatever people put on their client.
that would be good practice. But you know what? There is a bunch of people who don't follow good practice. So that's the
Not the
problem.
computer, it's the human.
Yeah, the problem is not the.
Yeah, but one of the points is that dynamic DNS requires the updates to happen, and because it has to be updatable file, mostly it is set up to be separate, and that's what the practice is, to put it in /var or somewhere. So
Yeah.
instead of putting it in the /pc bunch.
So here another thing.
But it is a variable file. All your data files are never going to go into etc.
Yeah.
Yeah, that's what I'm.
Here's another thing. Even if we are in a Linux group, I'm assuming that most people have been know about that funny thing that's named Active Directory. Okay? Active Directory loves dynamic stuff. And for whatever reason, the DNS servers from Microsoft and the protocol, I mean, not really the protocol, but the way that they're dealing with DNS and dynamic updates, they're registering a lot of names. And in theory, they should clean up when the computer disappears from the domain. They don't. And so when you connect to, when you have Active Directory somewhere and you see the same name used for a dozen of IP addresses, it's not a bug, it's a feature. It works that way. They don't. So DNS.
But that's DSCP. DSP does the same thing.
Yeah, but that's something that also happens is with dynamic DNS. If there is no good cleanup when the computer leaves the network, then you will have a lot of orphans and you will have some collisions and stuff like that. So probably good to stay away from it, except if you have a very, very, very good.
Want some reasons? But I mean, I can list a lot of them. That's the reason we want your machine's ID to be known by the server.
Yeah.
And that's simply because you have two machines communicate with one another. They need to verify each other's identity. Hence, you need that
would be one
part of it, right?
Yeah.
When you do all your little IoT devices, you need to be able to access them and not use a random IP that could change. Right?
Yeah.
I mean, there are lots of reasons for it.
When you
But
create
my little laptop just to browse? No, I don't need it.
So if the server, if the machine that you're connecting need to be registered in some ways because it's a device or it's a new server in the cloud and you're like creating gazillions of new servers in a second, then yeah, you probably want to have that. But otherwise, dig again and give me example.com. Example.com is a CNAME. It's an alias for web01.example.com, and web01 has that IP address. And of course, you can have the reverse, the pointer. Give me -x, the IP address, the name for that IP address, and it's going to be inverted. 10, 5, 4, 47 in added error R5. That's all the PTRs are set. And it works basically the same way with IPv6, except that, of course, the address is bigger. MX and TXT. So when you manage a mail server, you need to have some knowledge of DNS. Don't know anything about DNS, you don't know to provide a good mail service. The mail servers, the servers that are going to receive emails from the internet to your domain need to be registered with MX records. That says mail exchanger. That's the way to receive email. And more often, there is anti-spam techniques that are using TXT record to get some additional information about, is that mail server legit? Is that mail server blacklisted? Is yada, yada, yada. All those check to make sure that you're not letting spammers spamming your mailbox. Something that's important with MX, it really looks like a regular DNS record, except that there is an extra value, set a priority, because you can have multiple mail servers, one main mail server, and one or two backups. And you can set preferences about, okay, send any incoming email should go to the main primary mail server. And if that one is not responding, then yeah, you can go to the other ones. But by default, go to the first one first. And so this is something that you can set with the weight for each server. The lowest the value, the highest the priority. TXT record, there is a bunch of extra. So SPF, Sender Policy Framework, DKIM, Domain Key, Internet something, remember. And DMARC is another one to say, oh, we have list of authorized DNS servers, email servers that are listed into the DNS. We have some cryptographic keys that you can use to check if the emails that have been sent are legit, so and so. Could probably speak on that alone for an hour, so I'm not going to do that.
Those aren't really anti-spam protocols, they're anti-forgery protocols.
Of course, but it's to fight against spam in general.
Well, it just makes spammers not be able to forge someone else's domain.
Yeah. There is also some extra services that you can subscribe to. There is people who are maintaining a blacklist of bad domain, bad IP addresses, etc. And if you want to query those to make sure that the new email is not coming from something suspicious, then you can set a query to the DNS blacklist or real-time blacklist, and that relies on DNS as well. One of the most well-known service for that is Spamhaus, and they're like the primary provider for that kind of service. How does it look like? Give me the main server for example.com. Okay? So it's one long line, sorry, it doesn't fit. You have two mail servers in that domain, one that's MX01, one MX02, and the priority for the first one is 100, and priority for the second one is 50. The actual values don't really matter. It could be 1 and 2, 2 and 1. It's just a comparison between those two. It's not, 100 is not just better by itself, just bigger than 50, that's it. And give me a text record for example.com, and that's just one example for a SPF record that says everything that comes from smtp.example.com should match.
In this example, MX02 has a higher priority.
Yeah, sir.
Yes. Oh, my bad. Yeah, typo.
That's not.
Actually, I think that would have been a great little point to bring up. I thought love that. You go, yeah, it's not.
It's a good way to catch if people are paying attention.
Exactly. Thanks.
Yep.
Okay, something that's not very common, and that's something I like. You have all been connecting to a SSH box at some point, and the first thing that you get is, here's the key for that server. Do you trust the key? And what do you do most of the time? Yes. Tofu, trust on first use. And this is why SSH has been used by everybody and everywhere. It's because it relies on trust on first use. And it's good, because the first time that you connect to that SSH box, most of the time something that you know. And it's used really if there is a change later on and something suspicious happened, then could make the light going on. So something that's pretty nice is you can put the SSH fingerprint of your server into the DNS, and you can use SSH to say, okay, check on the DNS to see if there is a fingerprint for the server that I'm trying to reach, and if it's a match, then go for it. And you don't have to answer yes. That's really useful when you have a lot of SSH box and you don't have to and you don't want to check a list of 20 different fingerprints to see if it's a legit one or not.
And you trust DNS.
We will come back to that later.
But it also means that your SSH fingerprints are out there in the open, so anybody could sort of query for a SSH FP record.
But anyone can go to port 22 and get the fingerprint.
The fingerprint is public.
No, I'm not. But you could be using it on a different port. I mean, you could be not trying to tell people that this is an SSH server, but by doing this, you're essentially telling people that.
If you're using something different than port 22, yeah, indeed.
If you try to hide it by changing the port number, you're adding a couple of seconds to your attack.
Yeah.
But you're just trying to not make it obvious that.
But yeah, so just for you to know, when you want to use SSH FP records, you don't put the fingerprint as is straight into DNS, you need to convert it. And there is some tools that are going to do that for you and give you just the string of character to insert in your DNS record. But that's one that's kind of useful. Okay, you know all the basics to manage a DNS server, but at some point you will need to do some troubleshooting. So, let's look up that host. That doesn't do much good, but it's here. Dig, that's really your go-to tool for anything DNS. It runs on everything almost, and it talks DNS, DNSSEC. There is a bunch of options to make a short response, a short output, or detailed output. You can do DNSSEC queries, everything. So that's really your go-to tool. Drill, it's some specific tool provided with Unbound that I will discuss later. I know that's it out there. I've never been using it. I've never been in a situation when I need drill. So hopefully you don't need to worry too much about that.
It's for DNS secure.
Yep, it's for DNSSEC by default. Of course, you will have several logs to see how your server is running. By default, standard, most of the DNS servers are not logging the DNS activity. They are not logging all the queries and the responses, etc. They are just logging the activity of the service itself, about service is up, service is down, reload, restart, whatever. And nowadays, that's really not enough. I would probably recommend to start logging all the queries that you receive. Because that way you can have a better idea of how many queries you will receive and how much memory you need to allocate to your DNS server. That's one thing to make sure that, okay, is my server up to the task for so many clients? Then you can try to track that with the logs. Also, for security reasons, there is more and more stuff that goes with suspicious name that you can see if you have logs. If you don't have logs, you will never see that. There is also another tool that I've not been playing with yet. It's DNS Tap. It's to log the queries and all the activity, but not straight into the DNS software itself, but in a different part. So that way you can free up your DNS server, and it will. If you log everything, that will slow your DNS server because you write files somewhere and it's slow compared to UDP traffic. DNS Tap is a way to bypass that and to send the DNS logs elsewhere.
One more, INDC.
Sorry?
INDC. It's sort of like talking to the DNS daemon, telling it to turning on debug, turning on trace.
Yep.
What's going on, or
Yep.
how much memory you're grabbing and all that.
Yeah, there is that. It's just a little bit more intrusive. It's not something that you're going to put in production and run for long, I guess.
It's how you manage the daemon, right? So, for instance, when you do an update to your zone file,
That's
the file, that's the command you use to freeze
Yeah,
your zone.
I have that on another slide.
Okay.
Okay.
And to me, it's a tool that I cannot do DNS without.
Yeah, exactly. You have some other third-party tools. When you put a DNS server facing the public internet, you want to make sure that it's set properly. Of course, you've read the documentation. Of course, you've double-checked everything. Nevertheless, at some point, you may have forgot something somewhere, and it runs, and it doesn't complain, so you're happy. Nevertheless, there is those different websites where you can go and run some checks from an outside point of view, outside from your network. So that way you can check that, yes, all the domain and records are correctly set. I would recommend to run that on like every 6 months or so to make sure that you have not lost something when you're changing something. It's a good way to keep track on your domain. And you have also some public DNS servers that you can use: Google, VeriSign, OpenDNS, and so and so. Symantec, many. Some can trust those servers because they are really providing the good stuff and the real thing. Some other servers are going to give you an answer no matter what, exactly like your ISP does. Some other DNS, I think OpenDNS does, I'm not quite sure, don't quote me on that, are filtering some stuff. Because this is what they do, and they say, oh, you can use that domain server because we are filtering all the stuff that would be inappropriate for kids. Okay, what do you define as inappropriate? Because maybe a little bit, the definition may be different between you and me. So just be aware that when you are using public DNS servers, you need to check a little bit what kind of service they provide exactly. Of course, there is a security issues related to DNS because it's the cornerstone of the internet. So there is a fair number of people who have been trying to hijack DNS, to attack it, to attack the servers, etc., etc. And that's just a short list. It could be more than that. Some people can try to poison your DNS server to insert a wrong address, a wrong record in memory, and that address would be used then by other people connecting to your DNS server. And then they could redirect it to a fake bank website, fake whatever. So that's doable. It's not super easy. It requires good tools, but it's there. When you connect your laptop, your smartphone, whatsoever, in a public network, you don't know exactly what is responding to you, who is giving you an IP address. If it's an official DHCP server, you will most likely reach an official DNS server. If you have a rogue DHCP server, it will probably redirect you to a rogue DNS server, and then basically you have access to something that you don't know. So, especially in public service and public places, try to check a little bit what the DNS service that is provided to you.
If you know how, always use a VPN to a known trusted DNS server. If you don't know how to do that, use Google, which is 8.8.8.8.
That's one solution, but in some situation you can. For instance, here at Red Hat, I connected my laptop to the guest network, and I was thinking, okay, I'm going to use another DNS server because I want to check some stuff. Oh, network is filtered, and I'm not allowed to use anything else than the DNS server that's been provided by
DNS.
But it depends. In some network, it's super restricted, and you're not able to reach anything else. Be aware of that.
There's an ID.
Sorry?
You encode your internet packets into DNS queries for the so that it goes through your highly filtered network.
That's but technically it's doable. It's
super easy.
Something that I've already mentioned: a DNS manager will be able to trace everything you do if he wants to. So that's something that there is some serious privacy issue regarding DNS.
The way you're phrasing it, I have a problem. You mentioned when we started out, there was a lot of caching code.
Yeah.
So all you basically see is that at some point I ask for this address. It's not going to see every time I go there.
No.
And it's definitely not going to see what I'm using it for.
Yeah.
So yeah, if it says Gmail at Google or gmail.com, there's a good chance it's for mail, but it may not be.
Not be.
So it's not like they really see what you're doing. There's no data bingo, but they can certainly see what sites you've been on
Yeah.
at some point. Not whether you're spending 10 hours on this site versus 1 hour on that, but they can get a sense that you at least asked. But it could be something you're not even aware of.
That's true. It doesn't track all your activity, but it can lead to some conclusions. Depending if the websites or resources that you are reaching on the internet have a very significant name.
Mm-hmm.
If you're going to an hospital name, then you have some else. That's the kind of thing. I mean, same thing that you will have with your browsing history and search. But that's happening not only at the web level, it's happening at the DNS level. DNS server can be used for DDoS because you send a query, it's a small packet, the response is bigger, and everything is mostly you're running with UDP, so it's kind of easy to spoof, so it can be used to attack other services. So when you run an open DNS server, make sure it's not open to anybody on the internet because that's a bad thing, and you're going to be listed in a blacklist. And of course, anything would not be complete if, I mean, the NSA does some spying, especially on DNS. They have a program for that named Toplevel. That's what the NSA does.
And then some.
And spy agencies for other countries too.
I mentioned the big one. I'm not going. Okay. So I've already mentioned that when you're somewhere, check if the DNS server that you're using are good DNS servers. You can use a public DNS server, or you can run your own if you're interested in that kind of thing. And I'm still on. Okay, if you want to run your own DNS servers, I have a couple of recommendations. Bind, because that's by large the most well-known. You can find a lot of documentation, a lot of examples. It's almost provided by default in any Linux distro, etc. Bind is probably a good solution, except that it will probably provide too many features for what you need. If you just want a DNS cache, Unbound may be better suited. That is able to do everything under the sun, or almost, but you may not need all of that. So Bind is a good solution, but just take a look at the other ones before a final decision. NSD, oh, shoot. No, I'm good, okay. NSD is another name server that you can use to manage a zone. Unbound is not able to manage a zone, it manages only cache and recursive queries. DNS is something coming from Europe, and all those three are coming from Europe. And there is many more that you can look at.
DNS mask.
DNS mask.
I was going to ask.
Yeah, DNS mask is a small one. It has less features, but it's out there and it's easy to maintain.
In fact, it's recommended on your laptop run a DNS mask as a really local DNS. And then it can then figure out, you configure VPN, trusted DNS servers that keeps track of that and doesn't keep querying it.
I will mention something quite similar, not with that software, but with another one. So Bind, the full name is Berkeley Internet Name Domain. And it's developed by the Internet Software Consortium, IC. You may remember from one of the first slides, IC, they're running one of the root servers. So they probably know what they're doing. And that has been around since the 80s. That's like the first one. In the past, there were some serious security issues with Bind. God forbid that someone is still using Bind 4 somewhere. That's just garbage. DNS 8 something's probably not very good nowadays. Any version that you should run should be Bind 9, latest past version, etc. And you need to maintain that up to date, like for any other server that you may be running, but it's definitely true for DNS. It could be set as a cache and recursive or as an authoritative server. Technically, you can do everything at once. I would strongly advise against that. It's not a good idea to have a server that's authoritative and cache recursive. You one or the other. Your standard configuration file is going to be name.conf, plus a lot of files that you will manage. You can put everything in one file, but it's definitely not a good idea. You're going to split your configuration for each zone. So all those zone files are going to be included by name. And for those people who forget the dots and stuff like that, at the end, there is name checkconf that can check if you made a typo somewhere. And there is name checkzone that can see if you have everything set up exactly the way it should. And that's those two. I mean, there is more. Bind provides a lot of extra tools to make your life easier. So don't think, oh, I'm going to edit name.conf and go with it. No, you can use a couple of tools to check what you've been doing. And RNDC, that's the tool that you can that you will use to manage your daemon, to reload the configuration, restart, get some stats, etc., etc. You can do a lot more than just restarting the service. You can really go in detail with that. That's for bind. Another of my favorite is unbound. The name unbound came as a play on word against bind. People are doing that. It's developed by some people in Netherlands. Netherlands Net Labs is state-sponsored internet search center. I don't remember the exact status, but that's something that works for Netherlands. It doesn't manage any zones, which is, if you need to just a couple of records to manage manually, it can handle that, but it's not designed to manage zones, full zones. But for cache recursive server, it's very good. Very lightweight, very fast. There is one main configuration file, and there is the same kind of tools, and it's not the only one. That's one that I've listed, but there is also extra tools that you can use to check how your server is configured and how it's performing. If you want to install that on your laptop and you're moving around and using different DNS servers, there is an extra tool that is named DNS Trigger that you can use to say, oh, I'm using network at Starbucks. The DNS server provided by Starbucks are not good. I'm going to bypass that and use something. Or I'm connected to my university network. Servers are correct. They're doing a good job. I'm going to keep that. And DNSSEC trigger is managing that, including the DNSSEC level. But right now it's experimental. If you want to use that, be aware that it may break stuff. First time you try to use it and to connect it, I don't have access to anything because there is no valid DNSSEC server around. So it just falls down to nothing. But it's under development, so hopefully it's going to be better at some point. DNSSEC, so I've already mentioned that a couple of times. What it is. All the information that is in DNS is public. Everything that you put in DNS is not going to be secret for long. Someone will find it in one way or another. What's really important is, could you trust what the response that you're getting from another server? How can you make sure that there is no man in the middle playing with the response that you've received? The way to do that is to use cryptographic signatures to say, okay, the response came from that server, and the response has been signed with a set of private and public keys. And because you can use the public key, you can check if the response is correct and if it's been modified or not. And that's an extra step in DNS. That means that you will need to maintain cryptographic records on your DNS server. So that's going to be more management. Also means that the client need to make some extra check to make sure that everything's correct. It's not mandatory as right now. A lot of people are using DNS with not using DNSSEC, but hopefully over time it will get more and more common.
What happens if you have a recursive server and a first level server using DNSSEC, but once it connects, they do not use it, then how?
Okay, so that was really a situation at the very beginning of DNSSEC a couple of years ago, where you were doing your job, the people at the root were doing their job, and the one in the middle were not ready yet. At that time, and it's still doable nowadays, you can have an external service just for the validation. Delegation looking, I don't remember the DLV, I just remember the acronym. It's a way to check that your service provider is not able to do the verification, but you can use another service on the side for that. It's less and less common. Most of the top-level domain are signed with DNS.
There's been some huge DNS attacks in the last couple of years. They have to do this. There's no option.
Okay, so you need some cryptographic keys with DNSSEC. And you need one private key that will remain on your server because it's a private key and you keep that for yourself, it doesn't go anywhere else. And you have a public key that you need to publish for the whole world to use. Where do you put that key? In the DNS server itself. There is a kind of a chicken and egg problem because you need for everybody to know where the key is, but everybody's using only DNS, so you can put the key in DNS, but how can you make sure that's the real key because it's in DNS, not DNSSEC? There is some ways to
register with the domain registrar.
So basically, you will have a chain of trust that will go from your domain to your registrar to the top level that you're using to the root, and you can trace everything back to the root. I forgot that. A second. There is a tool named DNSViz that you can use to check online if everything's set properly. I didn't include that in the slides because the graph just for a basic zone is like super detailed and doesn't fit. But you can check that you have the key. The key that you are using has been somewhat approved or recognized by the top-level domain, and that top-level domain key has been recognized by the root. And you can check everything that. But that's only one pair of keys. You have two pairs of keys. One to manage all the connections back and forth, and one to sign the data in your zone. So basically, you have a zone signing key and a key signing key. So I'm not going to all the details because it's a pretty detailed topic and we'll probably not have time to cover all of that. But basically, you will need to manage two keys, one that will sign all your records and one that will make the connection between you and other domains. And because it's cryptography, that means that you need to change the key on a regular basis. And there is going to be a need for a key rollover. And you need to be aware of that when you start DNSSEC, because at the very first time, you will probably go to some serious troubleshooting to make it work. But that's just the first part. The next step is, how do I maintain that 6 months later to renew my keys? So you really need to have a plan. It's not something that your company or organization should decide about, oh, we're going to DNSSEC by the end of the week. Nope. You want to have a real plan. You need to know exactly who is going to be in charge, who is going to be checking on that, and maintain everything properly. And it makes the record like kind of bigger because you will have, I want the SOA with DNSSEC, and it gives me the exact same information than before with the signature, record signature. And there is a couple of numbers to say we are using algorithm XYZ and we are using the signature XYZ, etc. There is 2 dates here that says that key is valid from that day to that day. And after that, it's not valid anymore. You should not do a DNSSEC validation after that day. Like a security certificate on a website, same thing. So that's where all the tricks are. And then you have the key itself, and of course, for human beings, it's not really useful, but it's there. Do a lot of debugging and testing before going that way. It works, it's proven. reliable, but it's one serious extra step beyond DNS. But it brings a lot of bells and whistles. Because once you get DNS, probably remember SSHFP, the record that you can use to check on a SSH server. First time that you connect, you get the fingerprint. If you get the fingerprint just by DNS itself, it's not secure, so it could be spoofed. If it's coming, SSHFP is coming through DNSSEC, then you can check that's real, and you're good. DANE is something somewhat similar. It's a way for a web browser or any other service, email service are doing that as well. Could you, basically the query is going to be, could you provide me something to confirm that the security certificate for that service is correct? Could you provide me another piece of information to validate that the security certificate is correct when I'm connecting using TLS? And that way, you have DANE. You don't need to worry too much about certificate revocation, because you can do that straight with DNS, and even if your certificate provider doesn't do that well. And if you're running your own certificate authority internally, then you can make it public to the wide world if they're DNSSEC company. So because DANE require DNSSEC, not really widely spread right now, but it's one of the great benefits that you could get from that. You can really ease the burden on managing security certificates. Something else that's related to DNSSEC is it's not really new, but the decision to use it officially is new. CAA record, that kind of record in DNS will say, okay, the domain example.com is using a security certificate coming from Komodo. And any certificate that doesn't come from Komodo is suspicious. Then you can check that with that record. So that way, there is less chances for someone else to impersonate your web service or mail service by using another server and a different certificate. Because you can say only the certificate provider listed in that record are official. We're doing business with them. Anything else, not legit. And the CA Browser Forum has there was a vote a couple of months ago, February I think, and that thing will start to be mandatory by the end of the year. So some people will need to create new records just for that, because that's going to be a requirement for coming from the certification authority themselves.
That include encrypt.
Let's encrypt.
Let's encrypt. You can,
encrypt.
yep, because it's a CS, so it's a record on your DNS server, so you can list anything that you're using. If you're using Let's Encrypt, you just said I'm using Let's Encrypt. Anything else that I'm using that.
But that's good to know, because I have dozens of domains. Let's Encrypt.
So yep, you can start working on that.
Have that, or they're all going to break.
Yeah. Break or get a warning or something. I'm not sure that's going to be like completely broke, but yeah. DNS is not the only system that exists about.
And you have to have DNSSEC for that CAA record.
Technically, it works if you don't have DNSSEC, but of course, DNSSEC would make it better. I mean, there is a lot of stuff in the DNS world coming. The new ideas, new etc., that are assuming that people will deploy DNSSEC. It's not like it's going to be optional. Taking time, it's not easy, but it's the way it goes. DNS is not the only system that is used for name resolution. On a local network, even if you don't have any server, you may be able to join another machine with the name. What's that? Because there is MDNS, multicast DNS, that is official, etc. And it's using port TCP/3, and the MDNS messages are very close to the real one from DNS. It's almost the same protocol, on a different network port and with some different system to propagate. And on a Linux box, you will see it's managed by Havae. Bonjour is the software provided by Apple to manage that, and so that way you can have your smartphone able to connect to your smart TV even if you don't have a DNS server at home. That's what it does. There is also plenty of other ways to have other root or other DNS servers. This system. Cloud 42 was an experiment at some point. Some people were saying initially back in the day, oh, we cannot use numbers for top-level domain. Let's try this. Let's try to make a root with the numbers. And it works, and it stopped, etc. It was just an experiment. But it was working for a while. I'm not too very well versed in cryptocurrencies, but I know that Namepoint and Emmerpoint are using DNS to check on the validity of some cryptocurrencies transaction. So it's an extra step to use DNS for something else.
Well, Namecoin is an alternative to DNS.
It's at some level. You cannot switch fully to Namepoint. You use Namepoint only, you will lose everything else. It's one complement.
Right. Normally you map the .bit TLD to the Namecoin, so it's
a gateway to some extra service.
It's a blockchain domain registry.
Mm-hmm. It's just a way to access to some extra services.
The point is, there's no central registrar.
Yeah.
So it's blockchain based, and so there's no registrar, there's no central agency, there's
there is no central authority to manage everything, and that's
right. And so someone has your trademark name out of luck.
Yeah. OpenNIC is an organization that manages that kind of alternative routes. They are doing that for different special top-level domains. So if you want to know more, you can start looking at that. .onion is used by Tor. When you are using Tor service, you may have seen some name for reaching services on Tor, and that's just like unreadable because it's just like it looks like random characters. .onion, and that's a different way to manage naming because you don't have a central authority, you don't have registrars and the like. You just generate a name, you get that name, and you go with it. And on some other networks, you can use DHT, distributed H tables, something that's used on peer-to-peer network to say, oh, I have that piece of information, but just a little bit of information. I can provide you the information for that on my machine for the whole network. And other machines will provide other pieces of information. All the computers on the network knows a little bit about everything. And each time someone joins the network or leaves the network, then there is some mechanisms to make sure that everything stays up and running. That's used for BitTorrent and stuff like that. So you don't have names and IP addresses in the traditional ways, but you still have something that will let you connect to something else, using another mechanisms to figure where to connect.
The last say a little bit more about OpenNIC. The main motivation for them is one way of, with Namepoint also, deal with censorship. For instance, on OpenNIC, you will get the .ku domain for the Kurdish nation, which ICANN has not seen fit to assign a TLD.
So I've not discussed at all during the presentation about all the political part and economical part of DNS, because we have 15 minutes, but that's about it. There is a lot of political and economical implications on DNS, because who decides that country will get a top-level domain or not? That's a big question. How do you recognize a country and give them a presence on the internet? There is an economical part about, okay, who is paying for maintaining this and this and this and that? who should be allowed to create a new top-level domain if they provide a check with like 6 figures, that kind of thing. There is a lot of other questions that I've been discussing only about the technical part, most of it, but there is a lot of other questions about that. So maybe for another. The last slides are references. If you want to know more about this, then you have.
Very much.
That's the official resources where everything is listed for official purpose. DNS for rocket scientists, it's a good starting point to learn more about what are the different records, how to set up and configure your server name. Calomel has a good one-page tutorial on how to set up bound and one-page tutorial on how to set up unbound, depending which one you want. But that's a good starting point. Team Samru, they have different DNS-related tools that you can use. DNS servers and app toolbox. Those are books. That is like the Bible for DNS because that's the latest edition is a little bit old, but it's still a good starting point. That one is pretty recent and it's really focused only on security, both for Linux and Windows DNS servers. And there is other stuff that you can find online. If you want something more specific, you can ask me later. And there is, oops. And I missed one slide. I have another slide somewhere that has disappeared for some extra tools that you can use for troubleshooting. You can do some troubleshooting with Nmap. If you want to check DNSSEC, you can have an add-on in Firefox to do DNSSEC, that kind of things. And that's it.
Now, something as archaic, firewall with IP tables, is that so far simple and out of date and useless?
No, extremely
You
flexible.
still need a firewall.
I mean, that's what any decent firewall is built of, that or something like that. And the only thing you add to that is stuff to make it easy if you don't understand what's going on at the back, which may or may not be good, you know, which may be better than nothing, but generally to be really secure, you have to know what's going on at the back, IP tables.
Something related to firewalls and DNS. Sometimes people are thinking, oh, I need to block that domain. That's a bad domain somewhere. And I'm going to block that on my firewall. And most of the time people are looking in a way to put the domain name into the firewall configuration. I want to block whatever.com. Except that when your firewall will read the configuration, will look for, okay, whatever.com is that IP address, so I'm going to block that IP address. And your firewall stays up and it blocks stuff, and it works. And then at some point, whatever.com changed its IP address, but your firewall has no way to know that. So when you want to block something DNS related, the firewall is not the best place. You should filter something on the DNS server itself.
How do you do
What
that?
you do for websites is you use a web proxy firewall to force all the users to use the proxy.
You can use a proxy. You can set a blacklist in your DNS server itself. You can say null
But
root
that
or
doesn't stop them from going to the website. They can type in the IP address or use the spot.
depending on how.
So this is an interesting problem. So I use IPv6 via Hurricane Electric. And the problem is that Netflix has started blocking all IPv6 addresses through Hurricane Electric. Since I think last June it has been happening.
Okay.
So one day my daughter just tells me, "What have you done? I'm not able to access Netflix on my iPad."
I just told them you blacklisted my house line in your service.
Yeah, but there is also card.
So I was trying to use something that they have something called Z zones or something. I forgot what it is. But finally, I realized that there's one way in DNS mask to say that, okay, if it is going to be Netflix, instead of using my server, you use another server.
Yep.
And there's somebody written a small Python script which actually says, if it's Netflix, don't send it an IPv6 address, just send it an IPv4 address. And so
yeah, there is. So I didn't cover all those things because that's, for instance, in Bind, and it's true for other services as well. You can have something that's set as a view. So it works in two ways depending on where you are. Could be a view in Bind is okay. If you are a client with that network, coming from that network, I'm going to give you that response. But if you're coming from another network, I'm going to give you that
the
response.
split brain configuration.
Yeah, that's another way to put it. Yeah. And what's interesting is the two responses are completely valid, except that they're designed for different people. On the other hand, you can do something on the opposite about, okay, if I try to connect to that domain, use those DNS servers because they are fast or reliable or whatever. And if it's something in a different domain, then use another configuration. It really needs some tweaking. You're not going to do that on a regular basis for a lot of domains, but you can do it. I was doing that in a previous workplace where I have a DNS cache saying, okay, if you want an internal response, use the internal DNS. If you want an external response, use something else. And then you can split all the responses are sent or down. Yes? Full and complete, yeah.
Is that such
So the problem is with that, it really depends. When you go to yahoo.com or cnn.com, it's super well known and people will not really track you for that because it's common traffic. But let's say you are in another country somewhere where it's less of a democracy than here, and you're trying to go to Amnesty International website. The name will be very relevant. Someone will be able to check about, oh, you're trying to do this, or you're trying to get information about something that's not authorized. So that's where the matter is. It really depends how complete the name is, how meaningful it is. If it's something like computerxyz.com, yeah, okay, you're connected somewhere to do stuff.
Or let's say you're here and you want to see what a jihadist recruiting website looks like. So you go to look at it, and the next thing you know, FBI agents are showing up.
So here's the thing. There is a country in Europe that I know pretty well that has been doing exactly that. That has been telling by law to all ISP, you should blacklist at the DNS level all those websites. Everything including website related to terrorism and child pornography and all those bad things, which is probably a very good idea in some ways, except that
also includes some other
please,
things.
please, let me, thank you. Except that at some point, there was some mess up and entire other domain name have been blocked, including Wikipedia. And it was nationwide. I mean, for the full country, because of the internet service provider that with so many clients. And something different, there was, so it's in France, of course. We have some scientists that are doing social studies and try to understand how terrorism affect people and how they can enroll, etc. So they need to study those things, and they need to be able to reach websites. So at some point, the director of basically the research center nationwide has been writing to the government saying, no, please let us unblock those names into the DNS because we need to be able to do our work. So yes, there is some countries, there is some places where DNS is one of the many tools to block people to access to free information.
Your news if you're on corporate network, as the ways you
Yes.
now we're asking mothership behavior of how a use DNS is very different than an the of the DNS that you have also, because for example they have not because they're moving the IP address. Most legitimate places do that.
There is a couple of still a few minutes. Indeed, fighting against malware usually start nowadays at the DNS level because they are using odd, weird DNS names.
WannaCry.
I'm going to speak about WannaCry in a minute. Yeah, the DNS names are really odd, really weird. It's not something that a regular person would use. The domain name has been registered very recently. So if you get someone who connects to a DNS, a new name that has been created like 2 weeks ago, it's suspicious. Usually, I mean, it's not a usual pattern.
How do you determine that?
So there is databases that you can check online. You can use voice, but there is also more and more service providers that are listing recent new domain names that have been registered. There is security companies that are providing solution in a box to protect.
I was just wondering where that date was.
Yeah. I don't have name off top of my head, but yeah. The time to live are very short because they're trying to adjust and escape as quickly as they can. Also, and so this is about the WannaCry thing. When a security expert gets a sample of a malware, usually to analyze the malware, you don't put that on your laptop. You go to a lab and you have something cut from anything else, not connected to the internet because you don't want to propagate. And you're going to execute the malware on purpose to see what it does. And you're going to trace all of that. And one of the first thing is, oh, it's trying to use DNS. What are the domains that are involved with that? And to check on that, usually on that lab, you can run a special DNS server that will give a response for anything. Anything in the world, it exists. Doesn't matter. Like a special bubble. And WannaCry was trying to escape that kind of thing. About, okay, the WannaCry guy was thinking, okay, if someone brings my malware into a lab and try to connect to respond all the time, I'm going to detect that, and if I get a response for something that does not exist, that means that I'm in a lab and I'm not going to run. I stop. And the fact is, someone has been analyzing the malware, realized, oh, there is something going on, and the guy has been smarter to realize the domain does not exist. What if it does exist? And he realized if it exists, it doesn't run, and the domain is not registered. I'm going to register that name, and then any WannaCry copy in the world will realize, oh, the domain exists. I'm in a lab. I don't run. In fact, it was just a way to kill WannaCry. I mean, the first version to kill WannaCry everywhere, because the people who are creating malware knows all the people who are doing the analysis work. So they're trying to go around that. But yeah, just one way to do it. But yeah, definitely if you are on a large network in an enterprise organization, you want to run your own DNS servers internally because it's going to be better for performances and a lot of stuff. Just for the technical side, but from the security point of view, you log everything and you can analyze what's the regular pattern, what's business related, and what the outliers are. And depending on your responses, you can figure, oh, there is something wrong going on here. And you realize, oh, we have a bot or whatever. So that's a good way to start securing your network, is to have your own DNS in your organization.
I've been on NovaLUG's email list since probably about 1997, and it worked until about 2 years ago. And it stopped, and got an email telling me that I was, well, I put in for sort of will make your ignorant. And turns out the solution was in DNS, that you did have a reverse DNS lookup.
Yeah.
And that couldn't be done by my
Provider.
provider, Gandhi.net out of France. It had to be done by my ISP, Cox. And so I had to contact them and have them create
Good,
a
yeah.
reverse DNS.
For email, more and more often to try to have more and more level of protection against spam. The mail servers manager are checking that the sender has all the proper DNS records. If you try to send an email from an IP address, a naked IP address, it's going to be rejected almost anywhere, because the email system assumes that you're using DNS in the right way and you have all the records set properly. Plus, you have all those fancy SPF, DMARC, DKIM, etc. to track it against spam.
And more often, you want to send an email, you have to use a known provider. Meaning
Yep.
you have to set up an SMTP proxy. If you insist on running your own mail server, then you have to proxy to a known, because of all these additional requirements, security, anti-spam, all kinds of other stuff that is being added that most of us just
Don't have.
don't have the knowledge for. Right?
Yeah.
Well, actually, all those authentication is easily done, except for the RDNS, which actually is not needed to authenticate its email. The hello record is for that, but all the rest of them are just DNS records, which is why you're here today.
Yes and
It's
no,
not an
right?
issue.
But some of that DNS you don't have control of. That's your
No,
ISP's DNS.
everything except RDNS you have control of. If you run your own DNS server, which is why you're here today.
Technically, yes, but most people does not have the knowledge of how to do that.
Well, then, if you don't have, like he said, if you don't have the knowledge to run your own DNS server, you don't have the knowledge to run your own.
No. There's difference between running a little dumb DNS server for local naming in your own little home network versus running a secure DNS server with DNSSEC and everything else that comes with that. Those are two very different skills.
DNSSEC yet for email.
No, but
Actually, that's part of what our list is doing, not just the reverse.
yeah, at some point it will come, because it's been designed for that. So it would be.
But the email authentication mechanisms do not depend on DNSSEC.
No, for the authentication, no, but
Right.
for everything that's starting when you initiate the SMTP connection.
And that's,
No, I mean the authentication that you're not spoofing
but
someone
it's up to
else's
the
domain.
MTA to set that up, right? They don't, I mean, even Yahoo and some of these other bigger ones that have ignored email configurations and security for a long time are now finding themselves being excluded, I mean, exactly for the same reasons. Because they're not following what is now considered best practices. This is a complete different field. That the guy that have running our mailing list is literally part of running. So that's why he's implementing them way before anyone else does. But it's his implementation.
I've been running the mail servers all over the country for years now. So it's not a problem if you put the proper DNS records.
Well, that's one way. That's one option. What I'm saying is that's, I really, you look at DNS initially and, oh, it's just a little tree. It's easy to understand. And then the last hour of this discussion goes, holy crap, this is a lot more difficult than I thought, right?
Yeah, it's an old DNS is an old system, and people are adding more and more layers. So people who were expert in DNS 5 years ago, if they don't keep up,
No.
and for people who don't know DNS at all, then they need to, the learning curve is going to be a little bit more.
The SPF and KIM are really simple to do. You don't even need to run your own DNS server. Those will work fine on some random DNS provider.
Yeah, but nevertheless, For anyone starting network management nowadays, you need to be aware of everything that's coming. It's not, there is new stuff. Yes, one last.
I just want to say, if anyone has some time after this, I'm building a managed service provider's whole infrastructure out, and we're doing a split DNS type thing. I have like a quick 5-minute riddle for you on how we can make it work best, and you come see me afterwards.
Yeah, we have a nice whiteboard in the back.
Yeah, exactly.
Play that.
Yep. I probably have 20 more minutes before I need to go elsewhere, but I'm happy to stick around.
Are we done so we can close out the
Oh yeah,
broadcast?
sure. Goodbye. Thank you.